We know that a function has an inverse if it is one-to-one. So, what is a one-to-one function? Let me first give this information. A function is one-to-one if for 2 points, let's say x1 and x2, f of x1 is equal to f of x2 implies x1 equals x2. It's a mathematical description of one-to-one function. If you have this implication, it means the function is one-to-one. So, let me also write the second information. If a function f is one-to-one, then it has an inverse. It has an inverse. So it is a must condition. If it's not one-to-one, then it doesn't have an inverse. Okay? So, the second information, the graph of inverse and the graph of f itself is symmetric, okay, with respect to the line y equals x. It is the third information. The graph of f, graph of f inverse and f is symmetric, with respect to the line y equals x. So the graph of f inverse is a reflection of the graph of f in the line y equals x. It is the third fact. So I think now we are ready to give the main theorem, a useful calculus test for finding intervals on which a function is invertible. The theorem says that suppose that f is continuous, suppose f is continuous function, okay, on the interval, on the closed interval AB, okay, and also suppose that f is increasing at each point, at each point of open interval AB. For instance, when do we have this case? If f prime is always positive for each x in this open interval, then we can say that the function is increasing on this interval, right? Then if you have this case, then f is interval, then f is invertible. Okay, on this closed interval, and the inverse is defined on the closed interval f of a, f of b. Okay, it is the domain of f inverse. If f is decreasing, it is the second part of the theorem. If f is decreasing rather than increasing at each point of open interval AB, then the function f is still invertible, and the domain of f in this case, the domain of f, if f is decreasing, the domain of f inverse is equal to f of b, closed interval f of b, f of a. Okay, it is the main theorem about inverse functions. Now we are ready to give main theorem, main formula about derivative of inverse function. What do we have a theorem? Why do we have a theorem to take derivative of inverse functions? The aim is that we do not find the inverse, we directly find derivative of inverse without finding the inverse itself. It is the aim. So we are ready to give formula to find derivative of inverse functions. What about this equality? Is it true or not? Is it true? F of f inverse of x is equal to x. If you take f inverse of both sides, you will see that f inverse is equal to f inverse, right? So it is true. If we differentiate this identity with respect to the variable x, then we have, I differentiate with respect to x, then I have derivative also, I use the chain rule, derivative of f, I do not change the inside first, okay, times derivative of inside with respect to x is equal to derivative of right hand side is equal to 1, right? Now the aim here is to create for derivative of inverse function, right? So derivative of f inverse of x with respect to x is equal to 1 over this whole expression, f prime of f inverse of x. Okay, it is the formula for derivative of inverse function. So let's use this formula to solve the next question. Example, if a function is given as x cubed plus x, then find derivative of inverse at the point 10. Since f prime, which is 2x squared plus 1, is always positive, right, for each x, the function is increasing, f is increasing, okay. Also, it is increasing, and therefore it is 1 to 1, and therefore it is invertible, right, based on the above theorem. So it is an invertible function. So the question is meaningful. Let's say y is equal to f inverse of x. To solve this kind of problem, we use this identity, okay? So by this identity, you have, if you take f of each side, then you have x is equal to f of y, right? Instead of f of y, since f of x is x cubed plus x, f of y is equal to y cubed plus y. Now we differentiate. Do not forget the formula. How do we get the formula? Step by step we follow the formula, okay? We follow this procedure. Now we are ready to differentiate this equality with respect to the variable x. Derivative of left hand side is equal to 1. Derivative of right hand side is equal to 3y squared plus 1, derivative of 1, of course, the parenthesis y prime. Derivative of y cubed is equal to 3y squared times y prime plus derivative of y is y prime itself. So y prime in this case is equal to 1 over 3y squared plus 1. Okay. So what about the point 10? What about the point 10? Let's focus on the point 10 here. F inverse of 10 is equal to a. Now the aim is to find the number a. In this case, f of a is equal to 10. So the question is actually that for which number, for which variable, the function becomes 10. Look at the function. The function is x cubed plus x. For which value of x you have 10? It is 2, right? It is 2. So it is the derivative of y, derivative of inverse. If you look at the point 2, you see the answer. You find the answer, which is 1 over 13. Okay, I want to solve another question. I hope you understand the concept. Show that, the next question, show that f, which is equal to 4x cubed over x squared plus 1, has an inverse, I'm slow, and okay, this is the first part of the question, and the second part, find derivative of inverse of this of 2. Okay, so how do we show the first part? How do we show the function has an inverse? If we take the first derivative of the function and we see that for the first part of the question, if you find derivative, you will see that the derivative is positive for each x except the point 0. So f must be 1 to 1. So it has an inverse in this case. So we show the first part. Okay. What about the second part? It is the first part. For the second part, we again use the same identity. You give a name to the inverse. Let's say f inverse is equal to y. You take f of each sides. Okay. F of y in this case is equal to x. Then you write f of y here. What was f? F was 4x cubed for y cube plus, no, not plus, not anything else, y square plus 1 is equal to x. And in the next step, you differentiate each side of the equality with respect to x. If you differentiate with respect to x, then you have, finally, you have this result, the point 2. Let me clear this one. X equals 2. Okay. And finally you have y squared plus 1 square 4y to the power 4, 12y squared at the point 1. The result is 1 over 4. How do we find the point 2 here? How do we find the point 1 here? Okay, let me explain here the question. In the question you have to write. So f inverse of 2, when f inverse of 2 is equal to a, it means f of a is equal to 2. So it means for which value, for each variable of a you have 2. For y equals 1 you have 2. Okay, this is why I write y equals 1 here and plug this variable in this complicated expression. I hope you understand the derivative of inverse of functions.